In this episode, we are going to be creating a keypad from scratch. We are going to download the asset, we are going to load it into Blender to be modified, and then we are going to re-import it into Godot. We will then write all the logic needed for the player to input a code. We will of course validate this code with a success or error message, along with adding the appropriate sound effect for both. And finally, we will be adding a sound effect to our locked door, and the ability to unlock our doors using the keypad. So if we are going to be adding in a keypad, we are going to need an asset for a keypad. Now, a keypad is something that is a little bit more intricate to make as opposed to something like a door or a wheel. So we're actually going to go out and get this asset from a website. So one of the best websites to get free low poly models is actually poly.pizza. So as you can see, scrolling through, they have a lot of good free 3D models, and they have basically everything you could ever want. And most of them are either CCO or CC by attribution, which means that you just have to credit the person when you get it. So I found our security keypad on this website here. So this is licensed CCO by attribution. So Bruno Oliveira, thank you for your object. So definitely go check out PolyPizza for any of the models you need. And all we need to do is download this by clicking the download button. So go ahead and click download, and download it as a GLB file, not an OBJ. So download as GLB. And obviously you can see here that you have to include your attribution. So I'm just going to go ahead and click OK. And so here is our security keypad that has been downloaded. As you can see, it is one big model. Unfortunately, that is actually kind of a problem for us. You see, this model here is one mesh on its own. And one thing that we want to add to our keypad is we want to be able to press the buttons so that way they get pushed in. So what we're actually going to do is we're actually going to import this model into Blender, and we're going to manually separate the buttons into their own meshes that we can move. So if you don't know what Blender is essentially the industry standard for indie devs, game devs, any 3D modeling, any texturing, things of that nature. Everything is done in Blender. And that's because Blender is free and open source. So if you don't actually have Blender, it's completely free to get. Just go head over to blender.org/download. And I'm sure that many of you watching this video will have some experience with Blender. I think it just permeates so much of game dev culture. But because this tutorial is geared towards developers who are very new to the game dev ecosystem, if you will, I'm going to kind of go over this a little bit slower and a little bit more in depth, and I'm going to kind of say the buttons I'm pressing to kind of get Blender to work. At this point, make sure you have Blender downloaded and open, and just have it open to the base camera, cube, and light. So if you're new to Blender, Blender looks very intimidating. Obviously, there's all these different panels that completely change the way the UI works. For the sake of this tutorial, we're literally only going to use the Layout tab, and 9 times out of 10, anytime I've ever used Blender, it's basically been one tab, the Layout tab. So one thing that you probably need to get used to is if you have a mouse, the way you move the camera is by pressing your mouse wheel down. And if you're on a laptop, you won't be able to do that, but that's okay because what we're doing is simple enough that we don't need to be moving the camera around a whole bunch. I'm going to do it just because I think it makes the video quality better. And if you do intend to do any kind of game dev in the future and you don't have a mouse, you should really just pick up a cheap like $5 Amazon mouse because it's so much more useful in Godot and Blender. And if you try to take this seriously at some point, you're going to have to get used to Blender. All right, so rant over, let's go ahead and begin. So the way we're going to do this is we first need to get rid of everything in the scene, the camera, the cube, and the light. So go ahead and press A, press X, and then left click on delete. So that way we have nothing in our scene. Now we need to import the asset we downloaded. So go ahead and go to File, Import, and GLTF 2.0. Your GLB is most likely in your downloads folder here on the left. I put mine on my second disk, so here it is. So just go ahead and click on it and hit Import GLTF. So here's our keypad. It's in Blender. If you press G and then you can move it around. If you press Y, you can move it and lock it to the Y axis, just like that. I'm going to go ahead and right click so that goes back to normal. So the big problem with this, if you look in our scene collection over here, is that this is one entire mesh. And what that means is when we try to select, let's say one button here, we can't actually do it because it's attached to this mesh like this. And that's not going to make our buttons look good. So what we actually have to do is we have to separate each button individually, and that way we can import kind of the base mesh keypad and then the 12 various buttons. So the way we're going to do this is we're going to go up to this XYZ gizmo right here, and we're just going to click on the Y value. So that's going to lock us to the Y. I'm going to hold shift and then middle mouse button to move around a little bit. So I'm just going to zoom in. And now what we need to do is we need to select our keypad here. We need to hit tab, so that way we're in edit mode. As you can see, that's how we're selecting all the vertices. And one important thing we need to do is we need to go into wireframe mode. And the reason for that is if we are back in our just viewport shading mode and I try to grab these vertices, you'll see that I actually missed some in the back there. However, if I go back here and I go to wireframe, and I select all of them, you can see the entire button is highlighted. So now if I come back out and I hit GY, I can move the whole button on its own. You don't have to do that, that's just for demonstration. So anyway, back in edit mode and in wireframe mode, the way we're gonna do this, and we just need to left click and drag the vertices. Make sure you don't drag and get any of the other vertices or grab some over here. Make sure it's just your individual button, and we need to separate this by our selection. So the way you do that is you hit P and then you hit selection. So now let's go ahead and hit tab. We'll come back out of object mode and I'll turn on viewport shading. You don't have to follow along. This is just for demonstration. And if I select just node 1, you can see that I can move node 1, the entire button, irrespective of the base. So what we're going to do is when the player presses the button 7, it's going to push in and pop back out. And it's going to give a little tactile feedback to the user using the keypad. So back in our wireframe mode, hit the Y and come in here. The way we're going to do this is we're going to first label everything, and we're just going to call this top level 1 the base. We're going to grab the button that we just separated, this node 001, and we're just going to call this 07, just like that, to represent the 7th button. And now we just need to repeat that process for every button. I'll go ahead and do this next one. So I'm going to go ahead and select the base mesh here. I'm going to hit tab to go into edit mode. I'm going to hit 1 to make sure I'm in vertex select mode. I'm going to left click and drag around the button. I'm going to make sure I only have the button 8 selected. I'm going to press the P button and I'm going to click on by selection. So now I can go ahead and hit tab and come back into object mode. You'll now see that number 8 was labeled to base.001, and in the same vein, just label that to 08. So now if I come back out, I can see that if I press G and then Y, the 8 button can move just like the 7 button. So I'm going to go ahead and just do all the buttons real quick. Let's go ahead and do a time lapse. Alright, so now that that's done, all of our buttons should be able to freely move on the Y-axis, meaning we can push them in and the base will stay where it's at. I labeled my buttons 00 through 09. We have the base mesh, and then the clear button, the C button, is just clear, and then the OK button is just OK. So here we have it. We have modified our keypad object, and we can now export this to be used in Godot. So the way we're going to export this is File, Export, GLTF 2.0. You can export this wherever you want. You could export it directly into the game files. However, I'm going to put it on my D drive along with the other security pad, and I'm just going to call this capital mod underscore SEC underscore keypad and go ahead and hit export. So now all you need to do is drag and drop that keypad GLB file into your project. I created a new folder in my assets called keypad, and you should see your GLB. Now, if you double click on it, you can see that everything should load in fine. And most importantly, what you'll see is we should have 12, I think 13 different meshes. We'll have our 12 button meshes, and then we'll have the base mesh. Now, if anything went wrong with your editing of the keypad in Blender or the way it was imported into Godot, I don't want you to have to struggle. As a reminder, this entire project is uploaded to my GitHub page in the link in the description below. Feel free to grab it from there and just work off of that GLB. Also, if you need any help at all with Godot or Blender, don't forget I do have a Discord page. As a reminder, at the end of the weekend, I am closing the OG role. So if you join before the end of the weekend, you will get the OG role. That is something that I will never open up again. And if you want to be a part of that initial start of my community, go ahead and join the Discord using the link in the description below. But for now, we have a keypad. So go ahead and hit the plus sign. Create a new 3D scene, and we're just going to drag the keypad GLB file under this node 3D. I'm going to right click the keypad and I'm going to say make local. So that way we can now see all of our meshes here. So now we can right click the security keypad node, go ahead and make that the scene root, and just go ahead and delete that original node 3D. Now you don't have to do this, but I'm just kind of OCD, so I'm going to get the buttons in order, starting with 0 at the top, and then kind of going down incrementally. All right, so that makes me feel better. So now we have our keypad here, we have all of our meshes. The only problem is at this point, we have no collision. We have no way to actually press these buttons. So we are going to have to add a collision shape for each of these meshes. But also more importantly, each one of these meshes is going to have a static body 3D. Because if you remember, our interaction component can only interact with 1, a rigid body 3D or our physics objects, or 2, the static body 3D. So we need to make sure all 12 of our buttons are a static body 3D and have a collision shape. So we're going to go ahead and start with button 0. Just go ahead and click on the security keypad and hit Control A. We're going to go ahead and add a static body 3D, and we're going to name this SB00, which stands for static body 00. You're going to go ahead and just drag the mesh onto it. So as you can see here, the mesh is now a child. And now we need to make a collision shape for this static body. So I'm going to go ahead and go to the static body. I'm going to hit Control A. I'm going to hit Control A, sorry. And I'm going to add a collision shape 3D. Now obviously this shape can be a square, so just go ahead and create a new box shape. I'm going to go ahead and go into my gizmo and click on the z-axis, or sorry, maybe it's the negative z-axis here. Yep, the negative z-axis. And I'm going to shift move around and find this collision shape. So as you can see here, the collision shape is also blue. Let's go ahead and change that to red so maybe you can see it better. And it kind of sticks out a lot. So we need to shape this to what we need. So let's go ahead and do that now. We're going to drag it down like this, drag it across like this. And we want it to kind of be outside of the 0 button, so that way the player doesn't have to hit the button perfect. But we also want to make sure it's not going to interfere with any of the other buttons, so keep it kind of close. So let me go ahead and peer out here. Yeah, so let's go ahead and bring in like that. Bring it close to the button. So that looks pretty good. You want to have a little bit of room outside and around the edges, so that way we are able to collide with the 0 button. And once again, this is a process we just need to repeat for all 12 of our buttons. So I'm going to go ahead and go through that now. Alright, so now that we have all of our static bodies, we should just be able to copy and paste the collision shape we created for the 0 button onto anything else. So I'm going to grab this collision shape, I'm going to hit Control C, I'm going to click on static body 1 and hit Control V. And then after that, all I need to do is kind of drag it up. I'm going to hit that little gizmo again and drag it around the 1. So just like that. And we're just going to repeat this process once again for all of our buttons. Alright, so this is what your keypad should look like. As you can see, our collision shapes should all be around the buttons, but with enough gaps so that way you're not mistakenly hitting a button. I will say you should leave your base keypad not having a collision shape. It doesn't really make sense to, because 1, it's going to be on a wall, and 2, if you were to add a collision shape, you would have to ensure, that it does not overlap the existing buttons, because if it does, obviously the buttons will not work. So for my use case, I'm not even going to add a collision shape for the keypad. So of course, our screen is going to reflect the numbers we press, so we need to add some kind of label. So on the main root node, I'm going to add a label 3D. We're going to go ahead and go into the text and just hit 5 dashes, and we're going to go ahead and drag it up to roughly where the screen is going to be. So one thing you'll notice is that this font is not going to look good. So, you know, let's say I just put in like 1, 2, 3, 4, 5. 5. Actually, it's backwards, so go ahead and flip that 180 degrees. You'll notice that 1, the spacing is off, and 2, it's kind of blurry. So 2 things we're going to do is we are going to adjust the size of the label to make sure that the text comes out crystal clear, and we are also going to use a different font, one that is a little bit more digital and makes sense for a keypad. While we're here, just go ahead and change label 3D to screen, because we are going to be editing this in our code. we're going to right click and access as a unique name as well. So the font I chose for this is called Matrix Type. As you can see, it's very digital. It's kind of got a low poly, low fidelity look, and I think it's going to look good on our screen. So go ahead and download it. There's a couple different places you can download from. You can always just grab it from my GitHub page as well. So I just went ahead and imported this. As you can see, you get a whole bunch of different files that get imported, and if you're curious, you can always just double click on them and they'll give you a little bit of an example of what they're going to look like. So back on our screen, let's go ahead and click on this, and let's increase the size of our inspector a little bit just so you guys can see it. What we want to do is we want to drag whatever font we want over here to the font drop, just like that. So I went ahead and did the font display. You could do the bold if you wanted. I kind of like having the bars in between them. Now, one thing you'll notice is that the numbers are still extremely blurry. And the way we're going to fix that is by increasing the font size to something like 75. And then we're going to go into our transform for our screen, and we are going to set the scale to be 0.5. And now we just need to go ahead and adjust it so that way it is in the center, and that looks pretty good, maybe up here. So now the font is a little bit crisper. I'm going to go ahead and pull this back in so it's right on the keypad. There we go. That looks pretty good to me. And by default, I'm not going to have numbers just waiting there. What I'm going to do is have 5 dashes. You could just leave it blank. That might make more sense for your game. I think the dashes look a little bit better and kind of tell the player, hey, I'm looking for input. So now that we got all that, obviously we cannot be making a tutorial video without including our interaction component. So go into your interaction and drag your interaction component under the root node here. So that way we are ready to set everything up. Before we jump into code though, I want to demonstrate that we are going to be adding sound effects to the keypad as well. So these sound effects came from the Kenny asset pack as well. There are so many great sounds if you just search through them. So we're going to have a couple. So the first is a keypad press. And that's the sound that's going to happen when you click a single button. Then if you enter the right code, you're going to get a success playback. And then if you enter the wrong code, you'll get a failure playback. So with all of that, I think we're ready to start modifying some code. So let's go into our script. But first, we're going to go ahead and hit Control S. We're going to save our keypad, and we can just save it under our objects, and keypad is probably fine. So back in our interaction component, the first thing we need to do is we need to add a new interaction type, and this one is obviously going to be our keypad. So you can go ahead and go into your interaction component, set your object reference. I think setting it to the base mesh is probably the smartest one. The interaction type is not default. It is a keypad. It doesn't have a rotation. It doesn't have a pivot point. It doesn't have any nodes to affect, and it will have some sound effects. So in fact, let's go ahead and set up our sound effects next. So as you'll notice, we have 3 sound effects, but we only have 2 sound effects set up previously. So we're going to go ahead and create a third one. I decided to name this one our tertiary sound effect. As we add more and more sound effects to our objects, it's becoming more prevalent that the better way to handle this would probably be an array. So something like var sound effects, and this would be of type array of audio stream OGGs. However, I don't know if I'm going to go beyond 3 for the sake of this tutorial series, so I'm fine doing 3. But just as a heads up, if you're going to take this controller and use it to build a game with a lot more sound effects, this may be the better route to go. With that being said, we now need to set our sound effects. So we're going to use our keypad press as our primary sound effect. We are going to use keypad success as our secondary, and we're going to use keypad failure as our tertiary or third sound effect. And we will, of course, need to set up another audio driver. So let's go ahead and copy and paste the secondary code. And instead of secondary, you're just going to swap it out with tertiary, and that'll go for all the lines that have the audio player involved, as well as copy and pasting the sound effect down here. So make sure this matches. Oh, and I'm realizing we forgot to declare this. So up here, we need a new audio stream player 3D, and this is our tertiary audio player. All right, so now that we have our sound effects set up, let's go ahead and build out some of the variables that we're going to need for our keypad. So let's add a comment. This is our keypad variables. The first one we're going to need is an array of buttons, which is going to reference all of the buttons that we had. And this is going to be an array of static body 3Ds. The next variable we need is the code that the player is actually typing in. And this, of course, is an array of integers. Our next variable is actually the correct code. So create a new variable, var correct code. This is, of course, an array of integers as well. Now, what we could do with the correct code is hard code the value in here, and this was my example, 5, 6, 7, 8, 9. But if you have multiple keypads across the game, you wouldn't be able to reuse this, or if you did, you'd have to find some other way to set it up. So we are going to expose this using the @export variable, so that way when we hit save, we have to input the correct value here. So now 5, 6, 7, 8, 9 is just the default value, and then if you create a new keypad, you just need to change these numbers around. And of course, you could have more or less integers, but we do need to decide how many integers are going to be entered, or how long the code is, I guess. So create a variable that is max code length. This, of course, is an integer, and it's set to 5 because for my keypad, I only want a 5 code input. And the final variable we need is our screen label. This, of course, is a label 3D. That should be all the variables we need. So now let's go ahead and go down into our ready function. So here we have our door switch wheel note. We need another clause for our match statement. So we're going to check if this is the keypad. And if it is, we need to do two things. The first thing we need to do is say our screen label is equal to getParent.get node or null. And the node we are getting is obviously going to be screen. And remember what this is saying is get the parent, so the interaction component is on the root node. It's going to go up to the root node here. It's saying get node or null, so it's going to get the node screen, and because we're accessing screen as a unique name, it should be able to find it right here. And the next thing we need to do is we need to get the list of our buttons populated. So we're going to create a for loop. So we're going to say for node in getParent.getChildren. So this is going to get every single thing under our root node over here, and we're going to iterate over it. And so we're going to go ahead and check if the node is a static body 3D. This is the simplest way to find out because our buttons right here are all static body 3Ds. And if that's the case, we just want to append them onto the end of our buttons array. Now we need to create the logic for actually pressing the button. This is just going to be a no op for now, so we're just going to create a func. We're going to call it _press_button. This is going to take in a target, which is just a node, which should be fine, and it's going to return void. Now I'm just going to call return for now because we kind of need to set up how we're going to call this. So if we go back up to our different scripts, we have our pre-interact, we have our interact, and we have our post-interact. Now, you may want to think that you want to put it in the interact. However, you don't want to do that because the interact runs every frame that the player is clicking on the object. And so what will happen is if you press the button 3, you are not fast enough to only click it once. So you'll probably input 2 to 3 values of 3 and kind of mess up the code. What we actually want to do is we actually want to do it on the pre-interact, which runs once when the player first interacts with the object. And that's because we only want to click the button once. So let's go ahead and add a new clause. We're going to call our interaction type .keypad. And what we're going to do is in here, we're going to call our press button function. Now, you'll remember I set it up that this needs a target node. So go ahead and write target here. The problem is we don't actually have a target node. So if you remember way back when we did the object pickup, we passed the player's hand into the pre-interact to say, hey, this is where the object needs to move. We kind of need to do something in the opposite. We kind of need to know which button we're pressing. So every single object that we have interacted with so far has only been one static body. The box that we throw around, one static body. The door that we open and shut, one static body. The problem is now when we interact with the keypad, we have 12 different static bodies that we could be interacting with. But the interaction component doesn't sit underneath all 12 of them, it only sits next to them. So we need to tell the interaction component that's in the keypad which of the static bodies, i.e. which of the buttons we're actually pressing. And the way we're going to do this is we're going to pass this as an argument from the interaction controller. So we're going to go ahead and say we're going to pass in an argument target. This is going to be a node, but most importantly, we're going to say equals null. And this just sets it to null by default if we don't actually pass it in. And this will make more sense in a second. So let's go ahead and go back and find our interaction controller. So in our interaction controller script, if we scroll down to our else block here, remember this is the first time we're kind of interacting with this object, and we kind of have to do this handshake to pass information back and forth. So down here, when we call our pre-interact, we actually just want to go ahead and hit comma current object, because the current object is actually the static body that we're interacting with. So we're saying if we clicked on button 09, we are sending SB09 to the interaction component to perform the pre-interact. And you may also notice the other problem we have. So just to go ahead and show you this, I'm going to open the door scene. So in every other interactable that we've built, you'll notice one singular pattern. And that is that the interaction component sits as a child of the static or rigid body 3D. So here in our item, the interaction component is below here. Here on the door, the interaction component is below the door static body. If I go to our switch, you can see the pattern stays the same. And this works with our interaction controller because what we do is we hit the static body 3D and we say, get the interaction component. And so this checks the child nodes in the scene tree. That's going to be a problem for our keypad where the interaction component sits equal with every single static body that we have. So here, this logic needs to change slightly to be able to handle both of those scenarios. So go ahead and just copy this and set it off to the side. Maybe I'll just go ahead and hit enter. So the first thing that we need to do is we need to kind of cache the potential object. So we're just going to say var node, and this is going to equal our potential object. And so now at this point, we want to say that our interaction component is null, because it should be. And what we're going to do is we're going to iterate over this node until we potentially find an interaction component. So we're going to say while node, and then you can go ahead and paste the line that we left down here. The only difference is we're going to type in node. And so now that we have potentially found an interaction component, we need to check to see if it's null. So what we can go ahead and say here is if interaction component is not null, we're going to go ahead and break. Then if it is null, we're going to go ahead and get the parent. So let's go ahead and talk about why we're doing this and get rid of that line. So you'll see this block of code is what we've just added. So for our door example, our potential object is our door static body. So it's going to say the interaction component is the door static body, check its children for the interaction component. It will see that the interaction component is a child of the door static body, and it will break, meaning it will not finish out the rest of the while node, so it'll come right here. So now that we know that the interaction component is not null, it will continue on with the logic as it was. So let's talk about why this works for the keypad. So the keypad here, the potential object is going to be something like button 2. So it's going to say the interaction component is null, so it's going to check button 2 for an interaction component. Button 2 will not have it, so the interaction component will be null, meaning that the node is now set to the parent. Button 2's parent is the root node, and it'll go back through and check again. So then it'll say, is there an interaction component on the root node? And in this case, there is. And once again, we'll break and continue on. So it's slightly clunky. However, it does allow us to kind of recursively search through our interactables to find the interaction component and kind of make it work. All right, so at this point, we probably want to test to see if this is working. So go to your interaction component, go to your press button, and just go ahead and hit print, or type in print and print in the target. So this should tell us what button we are pressing. So now let's go ahead and go back into 3D, go back to the sandbox, and we're just going to drag the keypad in, and it's going to be very big for now, and that's probably fine. And let's go ahead and run the game. And I'm going to go ahead and hit 0. You might even be able to see it. 2, 3, 6, 7, 8, 9. And I'll go ahead and exit. And we'll look at the debugger, and as you can see, we now know which button we were pressing when we hit the press button instruction. So now that we know which button we're pressing, let's go ahead and update the screen, let's make some sound effects, and let's try to make this keypad actually work. So let's go down to our press button instruction, get rid of everything that was there, and kind of make a lot of space for this, because we are going to start programming and programming hard. So try to keep up with me. The first thing we are going to do is we're going to check if the target is null. So if there was no target and somehow it got called anyway, don't bother doing anything. The next thing we need to do is we need to check if the target is in buttons. Remember, buttons is the array of the array of buttons that are actually on the keypad. So if the target is not that, once again, this should probably never happen, but we always want to double check. So if we have clicked on one of the proper buttons, what we're going to do is we want to, remember, we want to tween the button, oops, should be in the Z-axis. We want to tween the button pressed in and then come back out, press in and then back out. So if we go ahead and go back into our script, where we are going to create a tween, and we can just do : equals, that'll set it to be a tween. We'll create the tween, and then we'll say tween dot tween property. We are going to tween the target, which is the button we're pressing, and we're going to tween it between its position Z, because that's the axis we want to move it on. And we want to do values from like 0.02. That's probably good enough. And then the duration, we want it to be quick, but we want the player to be able to see it, so we want to do 0.1. So essentially what this is going to do, it's going to push the button in over a period of like 0.1 seconds, which is quick, but you'll be able to see it. And then what we need to do is we need to pop it back out after that tween happens. So instead of going to 0.02, we want to go back to 0.0, and release back out over the same time frame is probably fine. All right, so now that we're moving the button, we want to play the sound effect. So we're going to call our primary audio player, and we're going to go ahead and call play. At this point, you could actually test and see if this is working. So if we run over to our keypad, I can press 3, and you can hear the noise, and you can see the buttons being pressed in. Awesome. However, now we need to actually make the keypad work. So after we've played the sound effect, we need to match. So we need to match the target.name. Now remember, this should be a space. The target name is the name of the button. So it's going to be something like SB00, SB01, SB clear, or SB OK. So the two most important ones are when the player clears the screen. So we're going to go ahead and just write return, and obviously when the player hits OK. And once again, I'm just going to hit return. So if it's anything else, then that means you just put an underscore colon, and that's kind of the default. So if it's not a clear or it's not an OK, it'll go into this clause here. And so obviously this is a number button. So we're going to say our variable num is equal to a string. So we're going to do target.getName. So if you remember, we have SB00. So we want to get that as a name. We're going to call dot substring, so dot substr, and that's going to take a value of 2. And then we're going to say dot to int. So if you remember, I just went ahead and added the print statement back. This is what the target gets printed out as. SB09 : static body, blah, 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 blah. We don't care about the static body unique ID. We only care about the button itself. So what are we actually doing? We're taking the target name, which becomes SB09. We're then taking this as a substring at the index of 2. So we're skipping S and B, which are at the 0 and 1 index, and that leaves us with just 09, but that of course is a string still, so then we say to int, and that'll give us the number 9. So now that we have that, let's go ahead and see if we can continue updating the code. So we're going to check if the entered code dot size is less than the max code length. So if you remember, these variables we created at the very start, way back at the start of this video. The entered code is just going to hold the value as we populate it, and we hard code the max code length to be 5. So this means that if we only have, let's say, 2 of the digits entered instead of all 5, we want to keep adding numbers as we go. So if we still have room, we still want to be able to add numbers. So we're going to say entered code dot append num. We are going to create a new variable, which is just going to be called text, which will be a string, and that'll just be equal to empty for now. So then we are going to iterate through all of the numbers that we have entered in the code so far, and we are going to build this string including all of them. And the reason we have to do this is because we are storing these values as a number. So we are going to take in the numbers from the code, make them a string, and then append them onto the text. So this text is an interior variable, so we actually need to set the screen label. So we'll say screen label dot text equals text. And then we also, we're going to change the color of the label. If it's a successful code enter, it'll be green. And if it's incorrect, it'll be red. Otherwise, it'll be white. So we need to call the modulate and set this to color.white. So that way, if you enter the code again after a success or a failure, it'll change the color back to white. So if you go ahead and run the game and hit start, we can come over to our keypad and see that it's updating in real time. And so if the player is trying to enter in more numbers than the code allows, you could fail it. You could do a couple things. I'm just going to say code is full for now because I don't have a great solution in my mind. So now that we're able to enter numbers, let's go back to the other conditions. So we have our clear condition. So if the player wants to get rid of all the numbers, this is actually very simple. We're going to say the entered code, which once again is an array, and we're just going to call clear, which is going to get rid of all the numbers in the array. And we're going to do the exact same line here. However, instead of setting the screen label to text, you could set it to blank, you could set it to whatever. My default is still 5 dashes. So if I go ahead and run the game and I hit 98547 and I spam this, you'll see that code is full, is printed down in the output. And then if I hit clear, all the numbers disappear and they are reset back to the 5 blank digits. All right, and finally, the most important code for our keypad here is in the OK. So we are going to go ahead and do if our entered code equals our correct code. What are we going to do? We are going to first take the screen label and we're going to change it to say something. I chose enter because that's also 5 digits and very easy. You could change it to something else. If it is correct, we want to change this to green because green means go, as in you can continue on. We're going to want to call our secondary audio player because that should be our success sound effect, I believe. And then just go ahead and put a hashtag unlock here because this is where we're going to do our unlock code, but we'll get to that in a second. So we also need an else block for our correct code. So go ahead and hit else. So in this case, the player has pressed OK, but they have not entered the correct code, whether it's too short, whether it's incorrect, maybe they didn't enter anything at all. Who knows? What we need to tell them is we need to set the screen label text, and we're going to say that this is error. Once again, a 5-letter word, you could make it anything you want. We are going to change this to the color red, and then instead of playing the success, we are going to play the tertiary audio player, which is our failure sound effect. So if I come over here and I say 745, I can clear it. If I hit 85474, you'll see that's an error. That actually sounded like the success sound effect, so I'm going to switch these, I think. Maybe I did that backwards. That's okay. Go ahead and hit play, and we'll try that again. If I hit OK. Yeah, that sounds like a failure. So then if I hit the correct input, so let's go ahead and clear 5, 6, 7, 8, 9, and hit OK, we are successful and we can enter. Oh, and one thing I did notice is that regardless of what happens after we press OK, we should be calling entered code.clear, so that way the player has to start fresh. So that way if I come in here and I hit 888 and hit OK, and I hit 7, we start with a new code. All right, so in preparation for our next step, I'm going to go ahead and take the keypad and I'm going to put it right next to our door, and I'm going to size it down for what is appropriate for a keypad. So I'm just going to grab this guy. I'm going to set its scale to be like 0.25. That feels like a good size keypad. We'll put it right next to the door. So now what we need to do is we need to set up our door such that it can be locked and the player cannot go through it until the keypad is entered. So the first thing we're going to do is set up our door to be locked. So I went ahead and found a door locked sound effect. So I just imported it here as an OGG in our sound effects folder. Here's what it sounds like. Sounds like someone trying to rip a door open, which is fine. So now let's go ahead and go back into our script and go to the top of our interaction component because we need to create some new variables. So in our door, we need to create a export variable. This export variable is underscore locked. This is a Boolean, and this is false by default because most doors you probably don't want locked. And then the next variable we need is variable was underscore just underscore locked. This is a Boolean, and this is false as well. Now, make sure you spell that correctly. The was just locked is going to be true if the door was locked on the previous frame and it has just been unlocked. In fact, it's probably better if we just call this was just unlocked. So that way this is true on the first frame that the door has been unlocked. Okay, so now we need to go down into our process function for our door, which is right here. And we need to change some things. So the first thing that we need to do is we need to check if the door is locked. So if I go into the sandbox and I open up my door, you will see that is locked is now on our interaction component. We want to set that to on, and we also want to update the tertiary sound effect to include our door locked sound effect. So now that that's set up, we need to check if the door was locked. So right here, after we calculate the door velocity, we want to check if is underscore locked. And if it is, we're going to set up some variables. So the first thing I'm going to do is I'm going to create a variable. I'm going to call this the lock wiggle. Lock wiggle is going to be a float, and it's going to be set to a value of 0.02. This value matches how far the door can open before the other sound effect will play. And it's just enough to kind of let the player push on the door without actually letting anything happen. Now, the next thing that we need to do is we need to set our door angle to be clamped because we don't want it to open too far. So the door angle is a clamp of the door angle between the door's starting rotation and the door's starting rotation plus the lock wiggle. Not is locked, lock wiggle. And then obviously we need to update the actual rotation of the door. So we say the pivot point dot rotation dot y is equal to the door angle. And now we need to decide if we should play a sound effect. So the first thing we need to do is we need to check if the door input is active, because we only want the sound effect to play if the player is actively pushing against the lock. So if they are actively pushing and the tertiary sound effect is set up and not the tertiary audio player dot playing, because we don't want to overlap or kind of reset the sound effect. And finally, we want to make sure that the previous door angle does not equal the current door angle, because if the player is just holding interact with the door but not actually moving it, it doesn't make sense that kind of shaking sound effect would play. So if all four of those conditions are met, we are then going to say the tertiary audio player, which is our sound effect, should play, and also that our door input.active is false. And so then everything else, which is the standard door behavior, should obviously happen when the door is unlocked. And make sure your previous door angle being set to the current door angle happens regardless of whether you go in or out of the if-else block. So let's go ahead and test it and see what this sounds like. So there you go, the player cannot open the door and a sound effect will play. So now we need to set it so that way our keypad can unlock the door and the door will work as before, as if it was never locked in the first place. So we need to add another method. So come on down here. Let's create this function. So we're going to call func unlock, and this is going to be set to void. This means we're going to say that is locked is obviously false. We are also going to set that variable was just unlocked equal to true, because this is going to fire once at the very start. Now, typically you're not going to lock any of the other interactables like a wheel or a switch. However, maybe you do. Maybe you want the wheel to only turn if the correct code is entered. In that case, this unlock function is going to be kind of agnostic to whatever interaction type it is. And so to do that, we're going to do another match on our interaction type and kind of set it up that way. So that way we don't try to set the pivot point on a wheel that doesn't have a pivot point. So if this is a door, and this is the only one we're actually going to be setting up in this video, we're going to set the door velocity back to 0 because we don't want the door to cache any velocity value from when the player is kind of ripping on it. We're going to set the door input active equal to false because, once again, we don't want any kind of movement on the door. We're going to set the door angle back to its starting rotation, and we're going to set the pivot point rotation dot y equal to the starting rotation as well. So essentially the door is just getting reset to its defaults because it's just unlocked, and we could run into issues where if the player pushes on the door too much, that velocity will just get cached, and then as soon as they unlock the door flies open out of nowhere. And so this will prevent that from happening. All right, and so then back up in our process function up here, we need to use our was just unlocked boolean to check. So right here under the interaction type door, it's going to be the first thing we do. We're going to check if our door was just unlocked. And if our door was just unlocked, let's go ahead and grab our unlock code here. Now, the reason this happens twice is because the process function gets called every frame regardless of whether or not we're interacting with the door. So even if we reset it, this could just get immediately overwritten in the process function. So if the door was just unlocked, what we want to do, if I go ahead and bring that back, we want to set our door angle back to its starting rotation. We want to set the pivot point of y back to its starting rotation. We want the door velocity to be 0. We want the door input active to be false. And then finally, after all this happens in the process function, we want to set this back to false as well. And so then if we just take this, put an else statement here, and populate everything else underneath it, this should get our door working. So now how do we actually link the keypad on the right to our door on the left? Now we've actually already set this up. We are going to use the nodes to effect array that we built many episodes ago, so that way the keypad can call the door and tell it to unlock. So if we go back down into our press button logic, you'll remember that we wrote a little comment here to tell us this is where our unlock is going to go, right? And so the way this is going to work is we're going to say for node in nodes to effect, because remember the nodes to effect is going to be populated in real time. So in all of our nodes to effect, we're going to check if that given node is not null, and if that node has the method unlock, in which case our door will, and if it does, then we're just going to call the unlock method. So now if I go back into 3D and I click on our keypad, I'm going to go ahead and set its children to be editable, so that way I can find its interaction component. Go ahead and close all these down, goodness. Find its interaction component, and I'm going to grab its nodes to effect. I'm going to increase its size to 1, and then I'm going to assign it to our door. In fact, I think I need to assign it to its interaction component specifically. So now, if I go ahead and run the game, I can run up to the door. It's locked. I can try to put in a code. That's wrong. The door will stay locked. And now, if I input the correct code, the door is now open. And we have a working door with a working keypad. So now just to demonstrate, we're going to go ahead and change this to a different code. We're going to say 18565. 18565. So now if I try to type in the old code, that's an error. It's locked. Let's say I want to do 18565. That's correct. And the door opens. This was a much longer and much more in-depth video than I planned on making, so if you stuck around until the very end, thank you so much. Make sure to check out the GitHub and the Discord if you need any help or have any questions. Thanks again, and I will see you all in the next one.